Okay, there are a lot of negative exponents in this problem, and so I'm going to start by simplifying some of them, namely this first division problem here. I'm going to rewrite that with positive exponents, a to the positive 3/4 power divided by m to the positive 3/2 power. And that is being multiplied by m to the negative 1/2 power, a to the 1/4 power, that thing raised to the negative 2nd power. And so now, well, this negative 2nd power, I'm going to look at this as an exponent rule. Is this the only way to look at this problem? No, but that's how I'm going to continue working with this problem. So I still have a to the 3/4 divided by m to the 3/2. And then I'm multiplying this. Well, negative 1/2 times a negative 2 is a positive 2/2, or 1. So I'm left with just m. A to the 1/4 times a negative 2 is a to the negative 2/4, or a to the negative 1/2 power. So a to the negative 1/2 power. Rewriting that, I could look at that as a still to the 3/4 over m to the 3/2 times m divided by a to the 1/2 power. And now we need to simplify our a's and our m's. So let's look at our a's. A to the 3/4, it's really being divided by a to the 1/2. So we would need to use our subtraction of exponents. 3/4 minus 1/2. 1/2 is also 2/4. Would give us a to the 1/4 power. And that would be in the numerator. So I have a to the 1/4 power. And then I have m, that's to the 1st power, minus m to the 3/2 power. Well, since I know I'm going to be working in halves, I'm going to change that 1st power, and that comes from my numerator to the 1st power, as 2/2 minus to the 3/2 power. Well, 2/2 minus 3/2 is a negative 1/2. So I have m to the negative 1/2. What that means is I have a to the 1/4, m to the negative 1/2 power. But I don't leave my equations with negative exponents. And so I'm going to rewrite that m to the negative 1/2 power. So my final answer will be a to the 1/4 power divided by, that's taking that m to the negative 1/2 and bringing it to the denominator, looking at that as the reciprocal of m to the positive 1/2 power.